Uh, Good evening. A warm welcome from QCrete Readymix Private Limited, and also this webinar number 43 QCrete webinar is conducted in association with Mangalore Concrete Center, Indian Concrete Institute Mangalore chapter, and all the officer bearers, Mr. Anil Baliga, and chairman of Mangalore Center. Everybody is on some other work emergency, so we are trying to do this in absence of them. Warm welcome to all the participants on this Saturday. Today's speaker is Dr. B. Kameshwar Rao Garu. He is from KLE University, Vijayawada. Small introduction about Dr. B. Kameshwar Rao, because he's a very learned and great man in the civil engineering field. He has done a lot of work, contributed a lot of things to civil engineering field, and we are from QCrete Concrete, Readymix Concrete. We are very fortunate to have him with us today, and I'm sure this webinar will add value to all the concrete technologies in some way or the other. Through his experience, he will propagate some ideas. So, sir, he did his BTech in 1977, National Institute of Technology, Warangal. 1980, National Institute of Technology, he completed MTech, and in 1986, he completed in structural engineering PhD in Indian Institute of Science, Bangalore, which is very big feather in his cap, I can say. And then he started working in Andhra Pradesh PWD department, engineering department, irrigation department as junior engineer. Then he became scientific assistant in Indian Institute of Science. The list is big, and the important things I will read out. Actually, he became chief scientist in CSIR Central Building Research Institute, Roorkee, March 2008 to 2013, which is a very big achievement. And then he was adjunct professor, National Institute of Technology, January 2014 to 16. Professor, Civil Engineering Department, VR Siddhartha Engineering College, June 2016 to 17. General Manager, Polavaram Irrigation Project. That is where I came to know about him more in Polavaram Irrigation Project, Andhra Pradesh. For a brief period, he worked there. And then now currently he's working as a professor in civil engineering department in KL University, Andhra Pradesh, Guntur district. So he has published many papers in national and international conferences, journals, more than 15 numbers, more than 15 keynote lectures. He has reviewed many papers. He has also contributed very importantly to the revision of BI specifications, about 4 numbers, participation in international ISO committee, participation in BSI committees, 8 numbers, and he has done a lot of work, guided a lot of students. That is very important, where he has always been involved in spreading awareness and knowledge in civil engineering. And he has also been doing a lot of work in high performance concrete by incorporating high volumes of fly ash, GGBS, and he has worked on enhancing the ductility of reinforced concrete by incorporating latexes and fibers, and a lot of more works like design of concrete mixes for longer service life and preparation of quality assurance plan for the construction of nuclear waste repositories, which is important. Development of performance criteria for durability of concrete for the design of concrete mixes, he has worked. Repair and retrofitting, he has worked. and he has also got involved in R&D activities, construction management, quality audit, and quality assurance of construction of buildings at 6 All India Institutes of Medical Sciences (AIIMS) coming in Bhopal, Bhubaneswar, Rishikesh, Patna, Jodhpur, and Raipur, which is a very important achievement, and which is the work is sponsored by Ministry of Health and Family Welfare. He has also done a lot of work on service life of fly ash concretes in aggressive environments, and the list is very big. As the time is limited, I'm stopping here. And more than anything else, Dr. B. Kameshwara Rao is a very simple, humble scientist, and he immediately agreed as soon as we asked, can you come on our platform and give a lecture on this Saturday? And we are thankful to you, sir. And now we leave the floor to you, and I'm sure all
Okay.
the attendees benefit from his lecture. Thank you, sir.
Thank you, sir. Thank you very much, sir. Thank you very much. And thank you very much for giving this opportunity to share my ideas with the August gathering. Okay. Now, I'll give the brief introduction about the concrete technology, the developments in concrete technology. Joseph Aspudin patented the Portland cement on 15th December 1824. Abrams developed the relation between water cement ratio and strength relation in 1918. He also developed the slump test 1920. Compaction test factor test was developed in 1940. Concrete mixed proportioning methods are being developed from 1950 onwards. Water reducing agents are being used from late 1960s. Superplasticizer has entered into Indian market in 1980s. Silica fume entered in Indian construction industry in 1990s. Calmet reported high volume fly ash concretes in 1986. Then high strength concretes were of more significant in late 1980s and early 1990s. The works on high performance concretes are being reported from 1994 onwards. The present scenario is like this. The present scenario is the many scientists and concrete technologists are working on service life prediction of RC structures, structural health monitoring, usage of nanomaterials in concrete, enhancing the ductility of the concrete, 3D printing, and also performance-based concrete mix proportioning. I want to spend this 1 hour time on the last item, that is performance-based concrete mix proportioning. Okay, that is the topic, today's topic. Okay, what is the performance criteria? We design a concrete mix for adequate strength to resist the different types of forces, and also we design for workability, and also another criteria, important criteria is durability, and the finally it has to be economical. Okay. The other considerations are the concrete mix has to be pumpable, and also it has to develop early strength in the case of chimneys and cooling towers, and development of lateral strength is required in the case of hydraulic structures, and also it has to be impervious in the case of the water tanks, and also it has to be it should have the volume stability in the case of precious concrete structures, and also it should give lesser heat of hydration in especially in hydraulic structures, that is mass concrete, and also it should have the self consolidation when there is a congestion of the reinforcement. These are all the requirements of the concrete mix. We have to proportion the concrete mix requiring to our needs. Okay. Then what I mean to say, there are mainly three criteria in the designing a concrete mix: strength, workability, and durability. There are adequate methods to quantify the strength and also adequate methods to quantify the workability, but there is no definite method to quantify the durability at the time of concrete mix proportioning. This I want to discuss in this 1 hour. How to quantify this, the durability at the time of concrete mix proportion. I want to address this topic. Okay. The ingredients of the concrete are cement, aggregates, water, admixtures, entrapped or entrant dies. Okay, the different types of we can develop different types of concretes depending upon our requirement. They are normal concretes, mass concreting, and ready-mix concreting, and also underwater concreting, roller compacted concreting, pumped concreting, sprayed concrete, that means shotcreting, cellular lightweight concreting, high strength concretes, self-compacting concretes, and the list goes on like this. The lightweight aggregate concretes, heavyweight aggregate concretes, high volume fly ash concretes, geopolymer concretes, and pervious concretes. Okay. Just I'll briefly just give the developments of concrete mix proportion. The volumetric proportions were used in early 1960s because awareness of concrete mix proportion was not there early 1960s. Proper awareness on chemical admixtures was not there up to early 1970s. Proper quality of fly ash was not available up to 1970s. After that, good quality of cements, the fly ash, the GGBS are available from 1980 onwards. The use of superplasters have revolutionized the concrete technology from 1980 onwards. If we look back, our limit state method was developed about 40 years back. At that time, the maximum strength was not more than M40. Now, with the use of this superplast silica fume, now we are getting M80, M100, and more. Because these two things have revolutionized concrete technology. And the use of blended cements and supplementary cement materials have enhanced the durability of the concrete. Yes, these are all the positive things. But nowadays, full potential of SCMs, that is supplementary cementitious materials, is not being utilized due to the prescriptive parameters adapted to take care of the durability. I will explain in detail in the due course of my lecture. Our journey is still miles to go in the development of concrete technology. That means instead of using the prescriptive parameters, we have to go for performance criteria in the concrete mix proportion. This I want to address. The relation, because over a period of time, different people have developed different relations and they have expressed these relations in terms of graphs or tables all over the world. And different countries have gathered all these relations together and keeping all these relations together, they have developed different concrete mixed design methodology. For a period of time, that more refinement has been taken place, and also with the improvement in the quality of the materials, our mixed design methodology also has changed from time to time. The main relations in the concrete mixed design, water cement ratio versus strength, the workability versus the total water content, maximum size of aggregate, air content, and also the relations between water cement ratio and aggregate cement, and also aggregate cement ratio versus the workability, maximum size of aggregate, shape, texture, gradation of aggregates, and also recommended workability for different types of earths. Okay, these are all the things. If we in nutshell see ASI method or our own method or British method, more or less these are all the relations involved in a different forms. Okay, I would like to briefly explain about ASI method and also IS method. The reason is I was involved in the revision of this IS 10262, IS 10262 2009 version. 2009 version. At that time, I was working in CBRA as scientist, and you know that first discussion took place about the revision of this code. That the need for the revision of this the mixed design code. It was the meeting held in Bangalore itself. So we know that this project IS 456 was released in Bangalore itself. The date was 1st August 2000. It was historical day. Why I say it is a historical day? Because the Veerappan has kidnapped the famous actor Rajkumar. On that day, we got down at Bangalore, Rajdhani Express. The entire Bangalore was full hartal. On that day only, this IS 456 was released in a bottle by Padma Shri Dr. H.C. Viswesvaraya. During that meeting itself, then the committee has discussed there is a need for the revision of this concrete mixed design code. But somehow it has taken more time for its revision. And then at a later stage, Dr. S.A. Reddy has been appointed as the chairman of the subcommittee for the revision of this IS 10262. Okay, there was a 6-member committee. I was a member in the committee. Then there was a discussion how to go about. Then in that subcommittee, I recommended that out of all methods, ACI method is the best method at that time. Then whatever the revision we have to do, it should be based on the ACI method. Yeah, the committee has agreed. Then just I'll briefly explain about the ACI method, how the ACI method was brought into Indian standard. Okay, these are the requirements of the maximum size of the aggregate as per the ACI method. I'm not going into details of this thing. And also these are the requirements of slums as per the ACI method. Okay, this everybody knows this thing. And this is the, because ACI, we know that ACI people, they give this relation between 28 days time and water cement ratio, the table of forum. This is for non-air entering concrete and also air entering concrete. Yeah. This is for the durability requirement as per ACI method. Yeah. This is the main relation. This is from where we have considered. So if you see this table, this ACI table, it's nothing to do with our own method. This entire set is a water content. For non-air entrant concrete, this is for air entrant concrete. Okay. Now you see this particular row. This is the water content. Water content for the slum, 25 to 50. And this is the size of aggregate is here, 9.5 mm. We have approximated to 10 mm. You say this particular size 19 mm. We have approximated to 20 mm. You see this size 37.5. We have approximated to 40 mm. So only we have picked up, because entire the method we cannot copy. We have picked up only these particular values only, and we have shown these values in our IS code 10262. Then you can see the 10 mm, 20 mm, and 40 mm, and this is the maximum water content. And maximum, see, you can see the title of this table, the maximum water content per cubic meter of concrete for nominal maximum size of aggregate for a slab 25 to 50 mm for angular shape aggregate, of course. So exactly. So with the certain modifications, certain approximations, we have changed these values and we brought these values to our code. Of course, there are certain correction factors for ACI code, and also we have adapted certain correction factors for different water cement ratios for different slums, for different shape of the concrete, and all those things, because we, and also what will be the water content if we use superplacization and all those things. We have given certain correction factor. So this is the one thing that my contribution was there with other country members. Then one more thing. So this is the original table of ACI method. So this is, you can see that this row, this is the finest modulus of the fine aggregate, 2.4, 2.6, 2.8, and then. So what are these values? That the volume of the aggregate, volume of the bulk volume of the aggregate. This is the bulk volume of the aggregate for different sizes of aggregate. And we have taken, instead of expressing the finest modulus like that, so we have expressed in a different way. Instead of finest modulus, we have expressed zone 4, zone 3, zone 2, zone 1. And as per the ACI method, these values are for the bulk value of the post aggregate. Bulk volume of post aggregate for different maximum size aggregate for a different finest modulus. Whereas this is not the bulk volume, this is the absolute volume. This solid volume of the post aggregate, solid volume of the post aggregate. There is a main difference. But one thing, there is a, so this is the, if you see the carefully the title, volume of the dry rodded post aggregate per unit volume of concrete for different finest modulus. See, this is called dry rodded, that means woven dried aggregate. Whereas in our code, we follow saturated, we assume saturated surface grade condition. We follow saturated surface grade condition. This is for unit volume of the concrete, whereas this is not for unit volume of concrete. This is volume of the post aggregate per unit volume of total aggregate, per unit volume total aggregate, and this is the solid volume. So these are the changes that I contributed along with others, and finally it was approved and it was borrowed. But one thing, I'll explain in detail now. Yeah, I'll explain in detail. So genesis of this matter 10262 2009 version. Okay, it was first published 1982 NCB. I also worked in NCB, National Council for 10 years. Okay, various requirements have been modified in line with IS 456 2000, and at that time it was discussed better remove this relation water symmetry to strength relation. It was totally removed, and requirement of entrapped air also was removed in that 2009 version. And illustrative mixed design examples were given in that code. Okay. And information required is grade of concrete, type of cement, maximum size of the normal size of aggregate, and all those things that required information for concrete mixed design. And we know I need to explain about this thing, target mean strength, that FCK plus 1.65 times the standard deviation. I need to so everybody knows. So this picture will be of the target mean, the relation between target mean strength and as characteristics. Target mean strength is 1.64 times the standard deviation plus the character strength. Yeah, these are all the values suggested for standard deviation. This is the assumed standard deviation, but actually if you have 30 minimum 30 values, you can calculate your own standard deviation and adapt the standard deviation in your concrete mixed design. Okay, the parameters employed, yeah, these are again the same table what I explained earlier and same table what I explained earlier, and this is the sieve analysis result as per 383 IS 383, the zone 1, zone 2, zone 3, zone 4. I need not explain about this thing. Okay, then what are the changes in 2019 version? Because after that 10260 has been further revised in 2019. Yeah, changes in IS 10262 2019 version. Separate guidelines have been provided for high strength concrete, mass concrete, and self-compacted concrete in this code. Earlier, these guidelines were not there. And different percentages of entrapped air has been recommended for different magnitudes. Earlier, entrapped air was removed. Now it has been reintroduced. And relations between water cement ratio and 28 days compressor strength have been provided. Earlier it was removed, now it has been introduced. Yeah. The other changes are certain ranges of percentage of mineral admixtures like fly ash, GGBS, metacolin, and silica have been specified for high strength concrete. Okay. 3 illustrative examples have been provided at the design of normal concretes with PPC, fly ash, and with GGBS. Separate examples have been provided for mass concrete, high strength concrete, and also that means total 6 illustrated examples have been provided in the revised 10262. Yeah, this is the relation between the target mean strength. The two relations have been given. FCK is equal to FCK plus 1.65 by standard deviation. Another relation is provided that a factor based on the grade of concrete factor, that is that F dash CK plus FCK plus X, that separate tables have been given. So this is the table for X value, the factor that a factor based on the grade X factor, that you can add this amount and for different grades of concrete, and this is assumed standard deviation as per the new code. Okay, and this is the percentage of entrapped weight for different sizes. For 10 mm it is 1.5% by volume, and 20% 1%, and for 40 mm 0.8%. And these are the curves, water cement ratio versus the 28 days curves. This is for 33 grades OPC, 43 grade OPC, then 53 grade OPC. Okay, that but one thing, there is small change between 2009 version and 2019 version. In some of the zones, these values have been changed. The solid volume of this porcelain volumes have been little bit changed in some of the cases. So this is the revised table. Okay, and these are all the doses of mineral admixture for high strength concretes. If you are designing high strength concrete, then your fly ash has to be between 15 to 30% in the concrete mix, and GGBS has to be between 25 and 50%, metacolumn 5 to 15%, silica fume 5 to 10%. Okay. And now I will come to the actual the picture. I want to discuss about the durability. That is the main theme of this lecture. Our IS 456 divides the exposure conditions to mild, moderate, severe, very severe, and extreme. And what is mild is defined very clearly in our code. And I'm not going to read this thing because everybody knows about this thing. The moderate, it is well defined in the code. The table number 3 of IS 456. Severe is the definition for severe condition, and very severe, well defined. Okay, extreme. Okay, this this is the classification. The of the 5 different exposure, 5 different exposure. Okay, now I am reproducing table number 5 of IS 456. So again, the same exposure: mild, moderate, severe, very severe, and extreme. This is for plain concrete. I'm not bothered with the plain concrete. I'm more bothered about the reinforced concrete. So certain prescriptive parameters have been given. That minimum cement content, maximum water cement ratio, minimum grade of concrete. Okay, now I want to address this thing in this lecture. Okay, these are called prescriptive parameters. Prescriptive means, suppose if you are designing concrete for severe condition, severe exposure, your minimum cement content has to be 320. Your maximum water cement ratio has to be 0.45 or minimum grade of effluent. See, you are prescribing a concrete with them, but you are not sure whether it is going to give your required durability or not. Okay, but I'll explain in detail. Yeah. Yeah, as I explained earlier, there are definite methods to quantify the strength and workability, but there is no definite method to quantify the durability. Yeah, as I explained that there are 2 types of parameters to consider the durability. One is prescriptive in nature, as I told, the minimum cement content, maximum water cement ratio, minimum grade of concrete. Then performance-based parameters. I will explain what are the performance. So these are the prescriptive based parameters, that is maximum water bend ratio, minimum cement content, and minimum compression. Apart from this, type of cement, whether it has to be OPC or PPC or PSC, are limits in the on the quantities of this supplementary cementation, whether it has to be 40% fly ash or 40% GGBS, or what has to be the how much percentage of supplementary cementitious material has to be there. Limits on the grading of the aggregate and dosage of the chemical admixtures and all those things. These are all the prescriptive parameters. What are the performance-based parameters? Heat of hydration. If you are if you are designing concrete mix for a mass concrete, your heat of hydration should not exceed this much. Porosity, pore size distribution. Permeability. Your permeability should not exceed this much. Your acidity, your pollutes should not exceed this so many. UPV, rebound hammer, and alkali aggregate, that mortar bar strength, mortar bar expansion, and resistance to abrasion and erosion. These are all performance-based parameters. Volume stability, expansion, contraction, resistance against the carbonation, resistance against corrosion of the reinforcement. These are all the performance-based parameters. Now we have to address our concrete mixes are this performance-based parameters. We have to address all instead of the prescriptive parameters. So why? Of course, we have to go. Why we get durability problems in concrete? Durability. The main problems are corrosion of the the reinforcing steel due to ingress of chloride ions or carbonation or due to the combination of both. This is the one reason. Another reason is cyclic effect of expansion and shrinkage due to alternate wetting and drying, cyclic effect of expansion and contraction due to the changes in the ambient temperature and the relative humidity, and a decomposition of the concrete and the leaching of lime due to the industrial and acidic environment. These are some of the durability problems. Okay. Now, what is the state of that? State of that? The durability of concrete is controlled by specifying certain requirements for concrete composition and characteristics of constituents, casting, compaction, curing, and compression. That is the prescriptive parameters. According to Hillsgrove, one scientist, what he says, this approach frequently yields unsatisfactory results, and it is a common objective of concrete researchers and engineers to develop performance criteria, performance criteria that would allow more reliable estimates. That was a statement given by Hillsgrove, 1989. Okay. In many codes and specifications, compressive strength of the concrete, the limit for the maximum water cement ratio, and the limit for the minimum cement content are used as criteria for ensuring durability. So it is generally accepted that concrete's resistance to the penetration of aggressive media largely governs the concrete durability. Therefore, a criterion that is based upon such resistance would be the most reliable approach. That means instead of prescriptive parameters, we have to go for performance-based parameters. The advantages that are not being exploited at the time of concrete mix design. What are the advantages? We are not underestimating. Pore filling effect of surface supplementary cementitious materials, which in turn reduce the permeability of concrete and improve the durability. We are underestimating their capability. The reduction in the permeability of concrete because of secondary reaction, which creates a dense microstructure in the case of supplementary cementation for a period of time. Okay, now you see, just I want to show this results. All these concretes have been developed for M30 grade, M30, and almost we got the same workability almost in all the cases. The plain concrete gave higher number of coulombs. And this, the fly ash concrete, it was made with 60% fly ash, very less number of coulombs. And slag concrete, it's like 50% slag was there. So these are the number of coulombs. And this is a combination of fly ash and microsilica. So if you close, these concretes are made with supplementary cementation. They gave very low permeability. That means they are highly durable, and we are underestimating their capability by using the prescriptive parameters. So if the permeability of the if we design this concrete at the permeability of the criteria, then we will be rationally utilizing this concrete, and we will be saving a lot of cement and also. Okay, this we know that there is a code, that ASTM C1202, that is for the RCPT code, and it has given certain value. High means more than the 4,000 coulombs, moderate between 2,000 and 4,000 coulombs, the low 1,000, 2,000, and very low certain amount of coulombs that it has. And this is our code. This is our code, the requirement. If you closely observe that this is now, this is the table from ASTM C1202. You see this classification: high, moderate, low, very low, negligible. And our classification almost it is same: mild, moderate, severe, very severe, and extreme. 5 classifications here and 5 classification here. High means you are allowing a high amount of chlorides. It is mild, equivalent to mild. Then the same name is given moderate, and severe means the low, like that. There is a similarity between this table and this table. Then why can't we adapt this system here so that Instead of these prescriptive parameters, we can adopt the performance-based parameter. That means expressing our durability in terms of coulombs. That means in terms of the permeability. I did some work in this area. Then during my tenure in CBRI, then because this is the so you see this is the values given by this code 1202, and whereas based on my estimates, I got this range: mild, moderate, severe, very severe, and extreme. So these are the coulombs. I did the number of trials. Then okay, and I got some tentative range of coulombs per unit per month. So now, so yeah, so why permeability is the most important factor. Why I want to address the durability in terms of permeability. The permeability ingress of, because that involves ingress of the aggressive solution and also removal of dissolved the reaction products from the out of the concrete. Lesser the permeability, the greater is the resistance to aggressive solution. Okay. So here I want to address one thing. The pure water, the water is a friendly material to the concrete during its mixing and curing. After that, it is not friendly material. It will be an enemy. The reason is, you see the molecular structure of the water, H2O. Two hydrogen, uh, two hydrogen ions are connected at one end. Because of this thing, there is a residual positive charge and also there is a residual negative charge. That's why this water molecule is called dipole, like dipole in nature. Because it is dipole in nature, what will happen? When this water enters into the capillary pore in the concrete, because of its dipole nature, it will try to attract more and more water molecules into the capillary pore and it will exert the pressure on the pore walls of the concrete. That's why when our slab is leaking in one monsoon season, we get sleepless nights. Suppose if you neglect that leakage in one monsoon, in other next monsoon, your leakage will be more severe. Okay, that is due to dipole nature of the water. I'll give one example. Suppose if you soak the chole or chana in water, what will happen after 4 or 5 hours? The chole or chana gets swollen because the water will enter into the grain, then it will soften the grain. Then sort of earlier, if you want to press with between two fingers, then you will not. After 4 or 5 hours, it will become softened, and because more and more water will enter into that grain, it will. That is one example. That because of dipole nature, the pure water itself is very dangerous for the concrete. So, because it exerts pressure on the pore walls, then it gives a rupture on the concrete. Okay. Then why I want to express durability in terms of permeability? Then I will explain the one by one. If you consider the sulfate attack, movement of the sulfate ions takes place through the transport of the fluids. That means sulfate attack depends upon the permeability. If you consider the chloride ion penetration, the moisture acts as the media for the diffusion or migration of the chlorides. That means the chloride ion penetration also depends upon the permeability. If you consider the carbonation, water molecules act as a vehicle for carrying carbon dioxide to the concrete. That means the carbonation also depends upon the permeability. If you consider the leaching of the lime, this also takes place through the movement of the moisture. Okay. And also if you consider the alkali aggregate reaction, movement of alkali ions to the aggregates and water to the swelling. That means ASR or AR, that also depends upon the permeability. If you consider the fire resistance, escape of steam from the heated layers causing spalling, and that also that means permeability is the root cause of all the durability problems. So we have to express our durability in terms of permeability. So the other the names of the diffusion, other facets of other mechanisms or definitions are diffusion, permeation, capillary suction, absorption, desorption, migration, all those things. I'm not going into definition of these terms. Okay. Okay, when we say the permeability of the concrete with respect to what? Permeability of concrete with respect to water, or permeability of concrete with respect to air, or permeable with chloride. Okay, nowadays we are developing M80 or M100 concretes. Then the measuring the permeability of the concrete with respect to water is impossible, because and also permeability is a, because this relation is not clear. Although the easiest way is to measure the permeability of the concrete in terms of chloride and penetration. That is RCPT. We did some work in this area. Okay, this is the permeability of concrete with respect to water, but the permeability of the concrete with respect to air, and this is the 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 diffusion. Then there are, when we talk about diffusion, there are three types of diffusion: gaseous diffusion, ionic diffusion, molecular diffusion. Okay. Okay, this is about RCPT. Just many people know what is RCPT, and also this is cell, and also so this cell. I need to elaborate this thing. Yeah, but only thing is just I'll explain something about RCPT. Then it takes care of diffusion, migration, capillary suction, adsorption, and desorption. This method was developed between 1981 and 1988 by D. Whiting from Federal State Highway Authority, and this was adopted by American Association of State and Highway Transportation, the AASTO, in 1990s, and by ASTM late 90s. It is easier and faster to conduct this test. It is well accepted test all over the world, but there is some criticism about this test. There is some criticism about it. What is the criticism? The specimen gets heated up due to high voltage. Other negatively charged ions also may get transported, and also this may not be suitable on concrete larger size aggregates. Chloride ions may get transported the weak interfaces, but even then, it is well accepted method all over the world. Okay, I want to give certain examples. With the 50% slag, so this one OPC, there are certain concrete tests, OPC with the water point ratio, water cement 0.34, 0.36, 0.41. You see the columns we got is between 1900 and 2100. With 50% replacement, we got very less number of columns. So that is because of this this GGBS, supplementary cementing, that means poor requirement by the GGBS. And so this another. So you can see that this is 25% slag and 50% slag. The higher the percent of slag, lesser the number of coulombs, and for different water cement ratios and all those things. Okay, we did some work in CBRI. The high value flyers are of course it was 50, 60, 70%. I am not going to explain all those things. Only thing is I want to show the coulombs values. Coulombs value. Yeah, this is a plain concrete. M30 grade concrete, M40, 50% fly and 60, 70, and it different days, 45 days, 90 days, 180 days, and 270. As the time goes on increasing, the number of coulombs gets reduced. That means there will be poor refinement within the concrete. With 70% fly ash, at 270 days, the number of coulombs was only 25. Number of coulombs, and it gave very good lateral strength also. By using the supplementation, I need not explain now at this stage. Everybody knows about it, but only thing is we are not properly utilizing these materials, and that is because we are adapting the prescriptive parameters, not the performance parameters. So we have to rationalize our concrete mix proportion. Yeah, these are all the relations that we got for M30 grade concrete. Yeah, this is percentage with respect to percentage of fly ash, and this on the y-axis is a plain concrete, and 50, you can see the 50. As the percentage increases, your number of coulombs. On y-axis, number of coulombs gets reduced. That means the number of coulombs that gets reduced with the increase in the percentage of the fly ash. So this is the case of empathic grade concrete. You can see that. Yeah. With this, that I want to, from my side, just I want to redefine the exposure conditions. How? The concretes located away from the coastal, urban, industrial environment that we can consider the mind. Concrete located in coastal environment and concretes located in urban environment. Concretes located in industrial environment and concretes used in hydraulic structures. This broad-based exposure conditions. Okay. Then another classification is interior concretes and exterior concretes. So your exterior concrete will have certain exposure than the interior concrete. That we have to distinguish between these two types of concretes. Okay, possible critical parameters for urban environment. If you are designing it and if you want to use the performance criteria or the design of concrete mixes, what what are the factors we should consider? Depth of carbonation, permeability, corrosion resistance. Possible critical parameters for coastal environment, diffusion of chloride ions, permeability, again corrosion resistance. And possible critical parameters for industrial environment, again diffusion of chloride ions, sulfate resistance, permeability, corrosion resistance, and all this. The possible critical parameters for hydraulic structures. So what should be the parameters for hydraulic structure? Heat of hydration, alkali silica reaction, permeability, acid attack. Here acid attack means the reaction of salt water with concrete. Yeah. Various critical parameters for pavements. If you are designing concrete for pavements, abrasion, frigid time, hydraulic structure, heat of hydration, abrasion, erosion, cavitation, ASR. Onshore structures, chloride penetration. Offshore structures, sulfate attack, chloride penetration, mass concrete, heat of hydration, bridge types, abrasion, frigid time, foundation, the sulfate attack, acid attack, metropolitan cities, carbonation, industrial environment, the acid attack, sulfate attack, chloride penetration, carbonation. Yeah, the relations to be developed because see, if we have to use the performance-based parameters, we have to develop certain relations. Without that, we cannot earlier because different people have developed different relations. All those relations we are using, and we have developed our own mixed design methodology. Now, a miles to go now because still a lot of work has to be done in this area. Okay, what are the relations to be developed? Compressor strength and the age at a different age. We have to find out the relation between compressor strength and coulombs, water binder ratio versus coulombs, and the percentage of each supplementary cementitious material and the coulombs at different ages, and also different cement content and the coulombs at different ages. These are all the relations to be developed. These are the gray areas or research guides. Yeah, we are doing some work here now. So this is the, you can see this graph, this is water binder ratio, 0.3. On the x-axis is percentage of fly ash, on y-axis it is the coulombs. You can see as the percentage of the fly ash increases, the number of coulombs got reduced. This is in the case of water binder ratio 0.3 at 28 days. At 28 days. So this is the relation for water binder ratio 0.4 at 28 days. The different percentage of fly ash. And this is for water binder ratio 0.5 at 28 days and for different percentage of fly ash. And we're trying to give certain equations for them. And all the three graphs combined together for 0.3, 0.4, 0.5 at 28 days. And 0.3 at 56 days, and 0.4 at 56 days, just 0.5 at 56 days. Then all the water binders together at 56 days. Again, 90 days, 0.3, 0.4 90 days, 0.5 90 days, and all the relations together at 90 days. And yeah, that earlier case was the fly ash, now it is GGBS. The similar graphs we can see for GGBS, 28 days point, like this. Just I'm quickly going through the line. Okay. Yeah. Okay, so far I tried to give the relations with respect to different water binder ratios and with respect to different personal fly ash, with respect to different personal GGBs, at for different number of days, number of days. Now, what are the other performance parameters? Because RCPT is not the only thing. Coulombs is not the only thing. There are other performance parameters. Other performance parameters. Accelerated rate of corrosion of embedded reinforcement. That means you can measure the rate of corrosion for different concretes under accelerated condition and express that rate of corrosion as the performance of that concrete, and also you can classify the performance in terms of the the percentage of the corrosion rate, and also one more relation could be diffusion of diffusion coefficient of diffusion coefficient of chlorides. You can measure the diffusion coefficient for different concretes and express diffusion coefficient as the performance parameter and carburation depths and abrasion distance. So I have done some work in this area. So you can see that I have embedded this reinforcement bars within the concrete. These are the cylinders, and I try to find out the rate of corrosion, the rate of corrosion for rate of corrosion at 90 days and 180 days, and for plain concrete, the two different rates, the 30, 40, and with 50% fly ash. And you see that at 70% fly ash, you can see at 90 days, the rate of corrosion is very, very less compared to the plain concrete. You can see at 180 days, you can see that this rate of corrosion is very low compared to the plain, 100 times less than that means. So we have to properly consider these performance parameters in the design of concrete mixes so that we can rationalize our concrete mixes. Yeah, and yeah, I would like to explain about diffusion coefficients. So I did some work during my tenure at CBR. Man, these are all the different water point ratios that 0.4, 0.5, 0.6, and this different personal slag, and these are the mixed proportions. And so this certain number of days that we have just drilled we have taken out the powder from the concrete specimen. We have analyzed for at a different depths, at a depth from 0 to 5 mm, 5 to 10 mm, and for 10 to 15 mm, and we have analyzed those powder and found the chloride content, and we have calculated the diffusion coefficient, and we found the diffusion coefficient with a higher percentage of slag is very, very less. So here also that we can express the performance of it in terms of the diffusion coefficient, or in terms of the rate of corrosion, or in terms of the coulombs. So we have to properly address this thing. The performance, yeah. I also did some work on carbonation. Just briefly, I'll go through. My slides. I think I'm not exceeding my time. It is 6:30. Okay. Okay, you can see that it is the corporation affected structure. It is Delhi, the Vigyan Bhavan Annex building. We initiated this building. Okay. There is a uniform corrosion here. So this uniform corrosion is due to the corporation effect. You can say the uniform corrosion. Yeah, we did some work. And before talking about the carbonation, I would like to explain about what are the ill effects of why we should worry about the carbonation. It increases the permeability and increase in shrinkage, and also it will affect the corrosion. What are the favorable conditions for carbonation to take place? Availability of the CO2 and relative humidity has to be between 50 and 75%, and also average pore size has to be more than 1000 extra units. What are the unfavorable conditions for the carbonation to take? When the relative humidity is between 0 and 50, it will not take. And also when the relative humidity is between 75 and 100, because pores will get saturated, the carbon dioxide cannot enter into that. Okay. And also when the pore size is less than 650 angstrom units, then also carbonation will not take place. Yeah. So this is the picture. This is the reinforcing steel. You can see this is the passive layer, you can see on the surface of the reinforcement state. You said the pink layer. Pink layer is uncarbonated zone. This is uncarbonated zone. So this is the surface of the. You can say, you can assume this is the column. You can see. So this is the portion which is not colored is a carbonated. Is carbonated. So yeah, this is, you can see that on the surface the pH could be less than 9. Okay, near the reinforcing steel, the normally it will be around 11 or 13. Okay, if it goes below 9, then you will get all that. This passive layer will get dissolved, then you will get the corrosion problem. So what we did, we have taken 3 different water band ratios, 0.3, 0.4, 0.5, and for each water cement ratio, whatever we have taken 3 different percentage of GGBS, fly ash, and also it was accelerated test. That we have taken a chamber. In that chamber, we have maintained 10% carbon dioxide, and we maintained relative humidity 70%. And these are the mixed proportions we have used. This is the chamber. In this chamber, closed chamber, we maintain 10% carbon dioxide, and we maintain the relative humidity 70%. Then what we have exposed the concrete specimens up to 1 year, and in between we have taken out some specimen and we have measured the carbonation. What we did at a required time, just we have broken the specimen and sprayed the phenylethylamine solution. You can see that freshly broken surface. You can see that the interior portion is showing pink color. That means it is not carbonated. Outer portion is showing the without it not showing any pink color. That means it is a carbonated. Okay. Then you can see now it is a water bind ratio, water cement 0.3 plain concrete. Even at 1 year, 365 days, no carbonation took place. Perfect. Okay. This water bind rate, water cement ratio 0.3 plain concrete at 365 days, no carbonation took place. And the water cement ratio 0.5, even after 1 year, in the accelerated condition, no carbonation took place. In the case of plain concrete, that is in the case of plain concrete. Now you can see the 20% fly ash. For 1 year, even after 1 year exposure, no carbonation took place with the 20% fly ash. And 0.4, 20% fly ash, here also carbonation did not take place. And 0.5%, 20, here also carbonation did not take place. And this is 0.3, 40% fly ash, no carbonation. I will show where the carbonation, yes. Now you can see 0.5 water bind ratio with the 40% fly ash. You can see that on the edges, there is a carbonation. On the edges, there is a carbonation. I'll quickly show this one. The way, yeah, this you can see quite interesting case. Water bind ratio 0.4, 60% fly ash. At 1 year, fully carbonated. At 180 days, you can see the progress of the carbonation. Of course, this is under accelerated condition. Yeah, now it's quite interesting case. Water bind ratio 0.5, 60% fly ash. You can see the carbonation started at 45 days itself. At 1 year, totally carbonated. Total. And this is the case of slag. I'll expand the cases where, yeah, you can see. Water bind ratio 0.5, 50% slag. Yes, there is a carbonation on the edges. You can see at 1 year, you can see. And 0.3 water bind ratio, 70% slag, no carbonation. Yes, 0.4, 70%, there is a carbonation on the edges. Yeah, it's quite interesting case. Water bind ratio 0.5, 70% slag. Yes, there is a carbonation, fully carbonated. Yeah, these are all the carbonation depths. Yeah, what are the findings? The findings are like this from this investigation. Carbonation did not affect concretes with the higher quantities of supplementary cementitious with the lower water bind ratio. Higher carbonation tests were observed with the higher quantities of SCMs with higher water bind ratios. Yeah, I mean to say a long journey to travel to the concrete. What is that journey? Standardization of test methods for rate of corrosion versus type of cementitious material and its water bond ratio, and specifying different rate of corrosion for different exposure conditions. Still, we have to develop these relations, and also diffusion coefficients for cementitious materials with the different water bond ratios, specify different diffusion coefficients for different exposure conditions. So, not all of finding these relations, there is another thing. We must validate the result, these parameters from time to time with the actual performance investable. This is the most important. Yeah, what are the recommendations for the future research? So still miles to go. Okay. Development of easy and accelerated methods and the equipment to determine the rate of corrosion, diffusion coefficients. Right now, that easy method is not available and also accelerated method. And this rate of corrosion you can only measure in a sophisticated laboratory, and ordinary laboratory is very difficult to measure. And also the diffusion, we have to develop easy methods to calculate the diffusion coefficient. And development of accelerated methods for carbonation, easy methods, that, and also performance evaluation of different protective coatings on concrete with respect to chloride and penetration, sulfate attack, carbon. I would like to elaborate this one because this is a very, very important thing. In our campus, there is a construction of STP, sewage treatment plant. You know that the pH value of the sewage is around, the pH value of the will be around 4 or 5. That is acidic in nature. So that means it will induce acid attack on the structure. So strictly speaking, that STP has to be designed for an extreme case. As per IS 446, extreme case. That means we have to adapt a mixed grade of concrete M40. What had happened? The person who has designed this STP did not consider this thing, and he is not aware of this durability criteria. What he did, he designed that STP for M25 grade itself. Now STP is now complete. We cannot do anything. We cannot convert that M25 to M40. So what is the solution? The solution is that we know that we have to understand what is the mechanism of this acid attack. You know that the pH of the concrete will be between 13 and 11, whereas the pH of the sewage water will be 4 or 5. At the interface, what will happen? At the interface between the sewage water and the concrete will tries to help the sewage and tries to neutralize the pH at the interface. And in order to neutralize the pH, it will release certain amount of calcium hydroxide. So in the due course of time, because the leaching will take place and concrete will become porous because of this acidic attack. So what is the remedy? Now you have constructed with the M25, not M40. The remedy is to create a barrier. Between the concrete and the sewage water. What is the barrier? It is a protective coating. So coal tar epoxy coating, we recommend it. With the coal tar epoxy coating, that coating will stand as a barrier. So now, with the chloride and penetration and sulfate attack and carbonation, is it necessary to design the concrete with a higher grade of concrete unnecessarily waste? So when we expect this chloride penetration and sulfate attack and carbonation, instead of designing a concrete with a higher grade of concrete, then after the completion of structure, we can use a protective coating. So that means we have to evaluate this protective coatings time to time and also the compatibility with the concretes. Then we'll be having a lot of savings. So this is one point I want to address to the August gathering. Okay, with this, I conclude my lecture, and I'm thankful to the organizer for giving the opportunity to share my ideas. Thank you.
Hello.
Hello.
Good evening,
Good evening.
Doctor. Doctor, now Anjali will pick up some questions from the audience and we'll ask some questions which are asked by the audience, and then
Okay. Okay.
and then we will you kindly try to answer, sir, please. Yeah.
Okay. Okay.
So the first question is why GGBS is used in concrete structure where chances of sulfate attack is high? And that was asked by Sumanta Sahu.
Okay. This both this GGBS and also the fly ash. They give, because both the GGBS and the fly ash, they are much finer than the cement. They are much finer than cement. They will give the pore filling effect, and also they give the extra amount of calcium silicate hydrate gel. They provide a dense microstructure. So with the dense microstructure, they resist the entry of these sulfates and chlorides and also the carbon dioxide. That is the reason why we have to use the GGBS in the concrete. Yeah, I think.
Thank you, sir.
Yeah.
Sir, only that question we have received for now.
Okay. Thank you.
Anjali madam, any other question?
Yes, sir. Yes, sir. Which type of superplasticizer provides the best dispersion of nanosilica in water for concrete preparation? And that was asked by Mr. F.A. Fakir Mohammed.
Oh, okay. Nowadays, we are using PC-based superplasticizers. Earlier, when superplasticizer came into the market, there are three types of super. It was story in 1980. Naphthalene-based, melamine-based, and lignosulfonates. Now, all those things are not there in the market now. Now we are polycarboxylate type of superplastic, PC-based superplastic. So here, the PC-based superplastic is the best one out of all the superplastic. That is the only thing that is there in the market. PC-based.
Thank you, sir. The
Well,
next question is, what would be the effect on durability on addition of calcium powder? That is seashell powder.
Seashell powder, seashell powder.
And
Sorry,
that
I
was
am not.
asked by Ashraf Ali Sheikh.
Sorry, I have not worked in this area, so I cannot comment anything on this since I have not worked in this area.
Okay, it's okay, sir. Thank you, sir.
Well,
Sir, yeah, we have done with the questions, sir.
yeah. Thank you. Thank you.
Doctor, hello.
Yes, sir.
Dr. B. Kameshwar Rao, you have done an excellent presentation, and I am Kaushik. I am from QCrete Readymix Private Limited. We are all thankful to you for this wonderful presentation, and I can say we have done many webinars actually, and I can say I can single out this as one of the most wonderful webinars has come across, actually, not because I'm from QCrete and we are hosting you. Some of the slides were very, very informative, and for example, we simply say, we have the habit of simply saying in our explanations that whenever uh, permeability reduces, durability increases. Okay, very simple logic actually. So you made a special size slide to explain why I want to express durability in terms of permeability. and you explained how ACI and Indian mix design procedures as per 10262 are related, and how you contributed to mix design codes like 10262, etc. And also you explained in detail about carbonation, which is a very hot topic. The moment somebody talks about high volume fly ash or high volume GGBS, especially I'm talking about high volume fly ash, people talk about carbonation. But you explained wonderfully that by controlling the water cement ratio, keeping water cement ratio to a very low level, carbonation can be controlled even when the fly ash levels are more. And most of your work, your explanations are based on your practical experience. That is very important to note. And as I said, I am sure most of the people, audience who have heard you today will benefit from your lecture. Once again, we are thankful on behalf of QCrete Readymix India Private Limited. And we are thankful to you, sir. We are extremely delighted to have you, and we are fortunate to hear from you. Thanks a lot, and hopefully we will host you once again at the earliest on other subjects. Thanks.
Okay.
Thanks a lot.
Okay, thank you. Thank you. Thank you.
And thanks for all the audience for spending your Saturday evening with us. And I'm sure Dr. Kameshwar Rao sir has imparted some knowledge today, and we will definitely host him another time on another subject. Thanks a lot on behalf of QCrete Readymix India Private Limited once again. Thank you. Have a nice weekend. We'll see you again. thank you, in the next coming week or something like that. Thank you. Bye.
Thank you.